So what is it? Okay, I'll wait for Janelle's, but we got to get started. Good, everyone. D. D, D, D. So pretty simple. Just remember to flip the sign. Flip the sign and take the square root of this value. So the square root of 169 is 13. So we know that the center is at 5, 3, and r equals 13. Does anyone have any questions on how to figure out the information based on the equation? Feeling pretty good about this topic? That's good. I graded, by the way, I graded everyone's homework last night. And I was happy to see that everybody got 100% on the assignment that was all about this. So good job to those students. And then if you haven't done it yet, when is the last day to do any makeup work for this class? When's the last possible day? I mentioned it briefly, I think. So the gradebook closes on Thursday, but if you want to get anything in before that, then you got to get it done by Wednesday at midnight, because I can't grade things during the day on Thursday. So everything has to be in by Wednesday at midnight. Any questions on that? Okay, cool. All right, so let's get into it. Today, like I said, we're reviewing circles. This is part 2 of our review. We're going to be covering similarity between circles, transformations of circles, the equations of circles, and then a little bit on radians, which I know it was a little bit challenging, as well as the approximation for the area using the parallelogram, which also was a little bit challenging. So definitely want to make sure we get to those problems at the end. Any questions before we get started? All right, like I mentioned, your test is tomorrow, part 1 tomorrow, part 2 on Thursday, and then you'll be free over the break. No geometry over the break, which will be really nice. All right, so starting with similarity. So as shown in the diagram below, circle A has a radius of 3 and circle B has a radius of 5. Use transformations to explain why circles A and B are similar. So in other words, what transformations can you use to go from A to B? If this is our pre-image and this is our image. All right, so a dilation and a translation, good. Now, translation, we can't really get more specific because there's no coordinate grid, so I don't know how far away everything is, but so we can leave it as that. But for dilation, we can be a little bit more specific because we have numbers here. So it's going to be a dilation with a scale factor of what? 5/3, very good. As a reminder, scale factor is image over pre-image. Okay, any questions so far? Okay, I need to pause for a second because I know Daniel just got here. Daniel, this question is specifically for you. I'm going to give you an option right now. I need you to answer it in the chat. So I know that you're going to be absent tomorrow and Thursday because I got a call from your mom, and we were supposed to take a test tomorrow and Thursday. So my question to you is, do you want to take your test today or do you want to take your test all the way after spring break? It's completely your choice. But just remember, if you take it all the way after spring break, you're going to have to study during spring break. Make your choice. You do it now, you get it over with. You leave it for spring break, you gotta study. What do you want to do? Do you want advice from your fellow classmates?
Yeah.
Okay. Class, what would you do if it was up to you? Take it now or take it after spring break?
If he feels prepared, then I think he should do it now. But if not,
I think I should do it now.
ready.
Okay. All right. So I'm going to allow you to do it now. Here's the
Okay.
deal. Since you're only doing it today, I'm only going to make you do part 1. So you're not going to do part 2 at all. But that means that part 1 is your final grade. Okay. So just make sure that you're trying hard.
Okay.
Okay. So what you're going to do, Daniel, I don't know. Can Miss Cressetta hear me?
Yeah, I'm here.
Okay, cool. Can he just be moved over somewhere kind of away in his own little corner so he can focus on the test?
Yes, I'll put him in the back of the room.
Okay, perfect.
All right, so,
All right.
and I think I'm gonna take her off of you though. That's cool with you guys? Yeah.
All right, Daniel. So you can leave the Zoom and I'm gonna release the test right now. So as soon as you can, just go ahead and go on to Performance Matters and get started. And best of luck. Okay?
Okay.
All right.
Okay.
You got this, Daniel. All right, let me just take care of that really quickly and then we can get started, guys. Okay. All right, we are good. So continuing, any questions on this problem?
No.
We good, we good? All right, let's do another one. So this one, let's do it in the poll. Same rules as yesterday. I want to see like 100% participation from everybody. And read carefully. This is transformations on Circle Q. All right, take 30 more seconds. I want to see more answers in the chat, or in the poll, I mean. All right, take another 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right. So not bad. Not bad. Let's take a look. So there were 3 people who chose B, and then 2 other people chose A and D. So let's just make sure that we're being careful about each part of this, because I think whoever chose A, I believe that you went backwards. So if you chose A, you were trying to transform circle R. But what is it telling us to do? It's telling us to transform circle Q. So we're going from Q to R. And if you're going from Q to R, you're going to get bigger, not smaller. So the dilation is going to be 2x and 2y, which narrows it down to answer choice B and D. But then if you're going from Q to R, I'm going 1, 2, 3 units to the right and 1, 2 units up. Since I'm going to the right and up, that's going to be plus 3 and plus 2. So it's going to be B. It's B. So questions on this one. How do we feel about this type of problem? Because there's definitely going to be something similar to this on your tests. So how do we feel? Are there any questions? Extremely good. That's good to hear. Anybody have any questions or concerns? Oh, Tyrone, you were the one who put it up first, who put your answer in first. Nice job. All right, cool. Let's do another. So now, no graph, but let's read it carefully and see what we end up with. Does anybody want to read? I know that those of you who are in school, I don't want to disturb Daniel too much. So those of you who are at home, can anybody start us off with this one?
Oh no, we put the volume really low, so.
Oh, okay, cool. Jalen, you just go for it. You sound like you really want to read today.
Actually, I don't.
Well, too bad. Go ahead.
So who? O'Brien?
Mm-hmm.
O'Brien?
O'Brien.
Okay, Miss O'Brien used a compass to draw 2 circles on a coordinate plane. Circle A is centered at 3, -1 and has a radius of 4 units. Circle B is centered at 4, 5 with a radius of 3. Select all of the transformation that could be performed on circle A to prove that it is similar to circle B.
All right, thank you. So no graphs, but we got numbers to work with. So use the numbers instead and see how we do on this type of problem. Go ahead. All right, it's been about a minute now. I don't see any answers yet. So does anyone have any questions? No questions, but also no answers. Interesting. Okay, there we go. Now they're coming in. Okay, 3 answers in so far out of 6. I'm still waiting on a few
Miss
more.
Daniel said he got locked out.
Okay, I'll unlock him. Let's go, y'all. Where are your answers? It can't take this long on a test. You'll be there forever. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so we have kind of all over the place, but the most popular responses were E and B. E and B. Now let's talk through them because I definitely see some misconceptions we got to talk about. So let's take a look. First of all, where am I going? A to B or B to A?
A to B.
A to B. Ooh, that was weird. A to B. A is located at 3, negative 1. And B is located at 4, 5. So if I'm going from 3 to 4 on the x-axis, how many units am I moving and in what direction? From 3 to 4. To the right, how many units? 1 to the right, good. 1 unit to the right. And if I'm going from negative 1 to positive 5 on the y-axis, what direction am I going and how many units? 6 units up. That's one way to think about it. Another way that you can do that mathematically is just to find the rise and find the run, because that's what rise and run is. The rise is how far up you go. The run is how far to the right or left you go. So if you subtract, you can also get the same answers. 5 minus negative 1 gives you 6. 4 minus 3 gives you 1. So 2 different ways to think about it. So between A and B, it's B. Now, rotations. Rotations. If I rotate a circle, am I changing anything about it? So do you need to use a rotation at all? No. Think about a wheel. If you rotate a wheel, it's not changing anything about the size of it. It's not changing where it's located. You're just rotating around and around and around. Nothing changes. So rotations are not used. They are not used in when you're trying to figure out if they're similar. So similarity does not require rotations, because rotations are not going to change anything. So it's like, why would you do it if it's just not going to do anything? Whereas translations, that's going to move you to the right spot, and dilations is going to make you the same size. But rotations and reflections aren't going to change anything about that circle, so there's no point in doing them. All right, so C and D, just incorrect answers. And nobody chose F, which is good, because F is also wrong. The dilation is a factor of 3 over 4, because we know that A has a radius of 4 units, B has a radius of 3 units, and we're always going to do image over pre-image, so the scale factor is 3 over 4, not the other way around. So it was just B and E. Who got it 100% right? I know there were a few of you. Tyrone? 100% correct? Perla and Janelle is 100% correct. Good. Nice job. So again, don't be fooled by rotations. They're not necessary at all. They're not going to change anything about the circle. Any other questions on this problem? Awesome. Okay, now back to equations of circles. Actually, hold on, before we do that, I want to do one more thing. Let me go back to this problem really quickly because I just realized I want to just make sure we go over something. Okay, so we're actually going to do something else really quickly. So let me delete this. So we already said the scale factor. What was the scale factor for this situation? 5/3, good. So here's the other part of this. What is the scale factor for the area of A and B? What would be the scale factor for the area? This is the scale factor for the radius. How about the area? It would. So the scale factor for the area would be 5/3 squared. But what does that equal? There you go, 25/9. So the area of circle B would be 25/9 times the area of circle A. Now, on the other hand, the circumference of B would be how much times the circumference of A? What would I need to multiply it by? Right here. Good, that would be 5/3. So let me actually move this over here. Okay, so don't forget that the circumference, the radius, the diameter, all of those kind of normal calculations have the same scale factor of 5/3. But for area specifically, the scale factor is squared. So that would be 25/9. So anytime that it asks you about the area, just remember you have to square it. Everything else, it's the same. It would be the same scale factor. Any questions on that? Okay. All right, now we can move on to this. Very similar to the bell ringer. I am sure everybody will get this one right. So go ahead and prove me right. 100% I'm looking for, 100%. Okay, 4 out of 6 students have voted. I'm waiting on 2 more. Give me 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We didn't get to 100, y'all. We were really close, really, really close. So let's make sure we understand. Who can explain why is it D and not B?
It always has to be the opposite.
Mhm.
So if on the graph it was -4, -3, in the equation, it has to be the opposite. So 4 comma 3.
Good. So we look for opposites. So this tells me that H is -4, K is -3, and what does the 9 tell me?
That the radius is 3.
The radius is 3. We take the square root of that value. So for that reason, it's D, not B. So we're almost at 100%. So specifically that one person who chose the wrong answer, let me know if you have any remaining questions on this type of problem. Shouldn't be too hard when you see this on a test. Cool. All right. So staying on this topic, we're talking about the equations of circles, but we know that sometimes it's not going to be written out in standard form. So we're going to have to go through that whole process. Like everyone who did this on Khan Academy got 100%. So I'm feeling good about this, but we definitely want to make sure we're practicing. What is the process? Where do I begin? I want to turn this into standard form.
You have to combine like the x's and the y's. Well, not combine, but put them together.
Good, bring them all together. So x squared minus 8x comes together. And then I've got y squared plus 2y, bring that together. And what do I do to that 8? Bring it to the other side. So all of this equals -8. Then what do I do? What's the next step in the process?
Oh wait, we're doing this together, not individually?
Oh yeah, sorry. I want to go over it, and then the next one is going to be
Oh, okay. we have to do the square thing, to complete the square.
completing the square. Okay, so how do I set it up for myself?
Make spaces.
Make some blank spaces. Good. So put a blank space after the x's, put a blank space after the y's, and we're going to be filling in the blanks. So how do I figure out what number goes here? We do have to divide something, Jalen. We divide by 2. Okay, so I take this number right here, divide that number by 2. What does that give me? -4. Then what do I do to the -4? We square it. Good. So put it to the power of 2. So I end up with 16. And what do you have to remember to do when you add it over here? We also add it to the right side, right? Because anytime that you're adding something on the left side, you want to balance your equation and add it to the right side as well. So we added 16 over here. Now what's going to be my magic number for the y terms? Good. Divided by 2, I get 1. 1 to the power of 2 is still 1. So I add 1 on both sides. And now I have my magic numbers. So don't forget that these magic numbers, they're going to be very important on the next step. Questions on completing the square. This step right here is the most important step. And first of all, if you haven't written this down yet in your notebook, then I don't know what you're waiting for. Please go ahead and write it down as we go through it. But does anyone have questions on completing the square? Okay. So next up, after I complete the square, what do I do? Okay, so I got to add up what's on this side. That's true. What about the left side? Good. On the left side, we're going to factor. So when we factor, that's where the magic number comes back. Because on the left side, I have x minus 4 squared. And I have y plus 1 squared. And when I combine like terms over here, I have 9. So factoring, okay, when you factor, you use your magic number. So for the x's, it was x minus 4 squared. And for the y, same thing, we're going to use the magic number. So it's y plus 1 squared. So this is definitely like, we've got to make sure we understand how to do each part of that process. Does anyone have questions? Pause here. If you're not sure where something came from, how I got one of those numbers, now's the chance to ask. All right, so based on this information, now I want to see 100%. Go ahead and answer in the poll. Good, I see 2 answers, 2 correct answers so far. It should not be taking this long. Take another 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. What do you guys think? Do you think we got 100%?
No.
No. Almost. Same thing as last time. Almost everybody chose the right answer, but we still have one person who is not learning from their mistakes. Why is it A and not C? Why is it A and not C? Who can explain?
I'll explain since nobody else wants to explain. It's always the opposite. So when you take those, it's like if you were gonna solve, you have to take them like individual equations. So x minus 4 would be x equals positive 4. And then if you were to solve y plus 1, it would be y equals negative 1.
Mm-hmm.
And
And
then
then-
9, oh, sorry, miss.
No, you go ahead.
Since it would be r squared, then that means that r squared is equal 9. So 3 times 3, which is 3 squared equals 9. So it would be 3.
Okay, good job. So your biggest mistake a lot of people make, you have to take the square root of that number because that number is your r squared. That's r squared. So in order to get r on its own, you have to take the square root. So big mistake people make all the time. But at this point, we've gone over this 2 times now. I don't want to see that mistake again. Next time we do this problem, which is going to be on the next slide, kind of, I want to see 100%. Okay, I say kind of because this one's a little bit more of a challenge problem. So I think let's do this one and then we'll go back to the challenge problem. I'm looking for 100, y'all. Give me 100%. Go ahead. All right, I see 4 votes are in, so give me another 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There we go. What do you guys think? Do you think we got 100?
No.
Why did it get worse? How come I literally just went over it and it got worse? That makes no sense. Makes no sense. What's the center of the circle?
-2, 1.
Approximately what is the radius of the circle?
1.5.
The radius?
3.5.
No, because it's 1. It's like
Mm.
1.75 or 1.5.
So what's the issue?
It's not exact. I don't know.
When we read the radius, you got to pay attention to the numbers on the axis. Yes, there's 3.5 boxes. But how much is each box?
0.5.
So I'm guessing we did worse on this problem, maybe because we didn't read it correctly. So I'm gonna give you guys a pass just for that, because at least you know what I am happy about is that A and B were wrong because both of A and B had the wrong center. So at least I know we understand this part, the switching of the signs. So I'm thinking that a lot of people chose the wrong response because of they didn't count carefully. How many units? We got 1 and almost 2, almost 2. So what's a good estimate for this?
1.75.
1.75, I think, is a good estimate. Okay, so because of that, it looked like it was 3. So if you chose answer choice D, you might have thought, okay, the radius is like 3.5, 3.5 squared. 3.5 squared would be around 12. So if you chose D, it's because you probably counted wrong. That was the trick to this problem. It's actually C. 1.75 to the power of 2. Check it out. Use your calculator.
Like 3.06. Like that.
Something like that,
Yeah,
yeah.
around it. That's why I got D.
0.625, something like that. So answer choice C is correct. So that's just a little thing. Like, I know that you want to be able to do these problems quickly, but you have to always pay attention to your axis. You can make that such an easy mistake to make if you're not careful and you're not reading those numbers carefully. So, okay, I'm not going to be too angry. I understand that that was a very common mistake, but now you can't get any more wrong. Okay, now that we've seen all the tricks that they might pull on you, you can't get fooled anymore. Understood? This is an easy A type of problem. I don't want to see any wrong answers on a problem that's this simple, okay? All right, now we'll go back. Now this one's a challenge. So I don't know, what do you guys think? Do you guys want to try it on your own or do you want to start it off together?
Maybe let's try it out on our own and then let's see if we can get it
Okay.
right. I don't know.
Okay, I'll give you guys a minute and a half to start it out, see how far you can go on your own of figuring out what you need to do, and then we'll go from there. I just realized there's a funny typo. That's equation, not equatrion. All right, take about 20 more seconds. And time. Okay, so this one it's a little bit tricky, but I know that you guys will easily figure out once I get you started with it. So they want to know what is the value of B. They tell you the radius. So that's a big hint, is they actually tell you what the radius is, and then you got to go backwards from there. So I have this equation. And I have this B here, but what I'm going to do is I'm going to leave it. I'm not going to worry too much about it. We're going to do what we usually do with this equation, which is, what do we have to do?
I'm sorry to interrupt you. Daniel got locked again.
Okay. All right, I got it. 1 second. It's loading very slowly, but okay, I just unlocked it. All right. So I have this equation, and in order to know the actual radius of the circle, what do I have to do to this equation? Is it in standard form? Right, Tyrone already knows. So we're gonna need to turn it into standard form. So we're gonna basically treat this like this question that we just did before. We're gonna do the same exact steps. So what do I do first? I have to turn it into standard form. What do I do?
Going to combine or not combine, but put them together. I don't know why I say combine.
That's okay. Bring together our like terms.
Miss, shouldn't we put like the radius squared too, like 49 as B, and then
No, because B is not the radius. Okay, B isn't the radius because you can only have the radius when it's written in standard form.
oh, okay, got it.
Okay, so it's not yet. Okay, so we write everything where it's supposed to be. I'm going to put in my blanks. And we go through and let's get our magic numbers. What's the magic number for X?
-2.
-2. -2 squared. I get 4. So +4. And then what's my magic number for the y's? 1. Kind of similar to the previous problem. A little bit different. Okay. So now I'm going to, I can finish this off and just factor it real quick. You don't have to do it, but I am going to do it just so we get a nice final answer. What goes in the blank inside the parentheses? -2 and +1. Good. It's the magic number. And on the right side, I have b + 5. Okay. Now I'm in standard form, right? And now that I'm in standard form, I know that this right here, that should be r squared since it's in standard form. So I know that b + 5 should equal what? 49. Good. And if b + 5 equals 49, what would be b? If b + 5 is 49, then b on its own should be 44, yeah. So it's C. So that was the tricky thing about this problem, is that the radius, you can only see the radius once it's in standard form. Once you get it into standard form, this has to be r squared. So what you guys did, and I know a couple people did this, was they thought that b was the radius. So you guys probably did 49 + 5 equals 54. So you guys kind of did it backwards. So take a moment and see. Now, I took a sneak peek of the test, and I don't believe that they're going to ask a question that is this challenging. However, if you understand this question, then anything that's a little more simple should be very easy. So make sure you understand this, because it doesn't hurt to do things that are harder than the test, right? Any questions? Great. All right. Moving right on. Moving right on to everyone's favorite topic, the approximation of the area. So we'll start it easy. I'll give you guys a couple of more challenging questions, and then we'll see. And remember that with this type of problem, it all comes down to making sure that you know the definitions. So go ahead and take a look. Starting it off pretty easy, in my opinion. Go ahead and try to get your answers in the poll. An ellipse is it's kind of like an oval, but it's more precise than an oval. It's a specific type of oval. All right, I see 2 answers in so far. All right, 3 answers in. Take another 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Good. Looks like 100% to me. That's good. So yeah, with a circle, the way that we approximate the area is you take your circle and you basically cut it into a bunch of slices like you would with a pizza or a pie or a cake. You slice it, you slice it, you slice it, and eventually you get all of these nice slices and you can rearrange them into a parallelogram. So if this is 6, 7, I have 8 slices here. 1, 2, 3, 4, 5, 6, 7, 8. Oops, this has more, much more. This one has 12 slices. So I could keep going, and you can keep going and going and going. And actually, what happens as you keep going? So if I keep slicing these in half and creating more and more triangles, what happens?
The radius gets, I mean, the height gets closer to the radius.
The height of each triangle, good, and of your trapezoid, of your not trapezoid, of your parallelogram is going to get closer and closer to the radius, which means that the approximation gets what? Because remember, an approximation is not exact, but the more slices you have, what happens to the approximation?
It gets more accurate.
Good, that's exactly correct. It gets more accurate. So the more slices you take out of your circle, the more accurate the approximation will be. It becomes more exact. Yeah, that's another way to say it. So it is area of a parallelogram, not an ellipse, not a triangle, not an oval. Now let's get into it a little bit more. This was from your quiz, I believe. So I think we actually already went over it yesterday. But basically, let me actually go through it here. Let me explain this because I just want to make sure that we totally understand this part of it. So let me go ahead and do this again. And this time I'll have the correct amount of slices. So it's 12 slices, right? Okay, now I got to split these into 3. All right, that should be 12. Awesome. So let's say I took all these slices and I arranged them in this way. So let me label them again. Okay. And I have this bottom section. And if you think of these blue parts as the crust, how many crust slices, how many crusts do I have on the bottom? 6, right? I have the crust from number 2, from number 4, from number 6, from number 8, 10, and 12. Okay? So it's half of your pie, half of the whole pizza. Now the crust is on the outside, so the crust is the circumference. So how much of the circumference is represented by the blue line? Six out of 12. So like Tyrone kind of already said it, it's half of the circumference. 1/2 of the circumference. Right? If we're only looking at the blue sections, that's 1/2 of the whole circumference. Well, what's the circumference of a circle again? What's the formula, please? Formula for circumference. circumference is 2 pi r. 2 pi r. So what would be the formula for 1/2 of the circumference?
Pi r.
Just 1 pi r, yeah. Just pi r. So that means that the base of my trapezoid, the base is pi r. Just pi r, because it's half of the circumference. The other half is up here. So that's the base. Now the height of this parallelogram, the height is this part of my triangle. And that part of my triangle corresponds to the what? On my circle. What is that? That's the radius. Now, this is approximate. Remember, this is approximately the same as the radius, and this base is approximately the same as the circumference, half of the circumference. So the whole area, remember, area equals base times height. The area is going to be pi r times r, which is how we end up with, area equals pi r squared. So big thing to remember is that the base is pi r and the height is r. Alrighty, any questions on that? That is the definition. Very easy to just try and memorize it as best you can. The base is pi r and the height is r. No questions? Okay. So I'm going to skip this one because we did it yesterday. But let's go ahead and take a look at this one. So this one's a select all question. I know that there's a lot of selections, but it's actually not too bad because if you choose A, then you're not going to choose B or C. If you choose D, then you're not going to choose, it's like one or the other. Okay, so let's see. Let's do, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. I only have 6. 1, 2, 3, 4, 5, 6. So instead of doing it in the poll, just send me your answers in the chat privately. All right, go ahead and take about a minute. And yes, Tyrone, so you should only get 4 options if one of them is right and the other one is wrong. Or they might both be wrong, so just be careful. Good, so far I'm seeing good responses. Give yourself another 30 seconds. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, looking good, looking good. So first, just looking at A, B, and C, because only one of them can be right. These are all talking about the same thing, so they can't all be right, or it can't be more than one. It's only going to be one of those. So the length of the base We just went over this. What's that going to be? The base, not A, B, pi r. The base is pi r. Okay. What about the height? Only one of those is correct. The height is just r. So it's not D, it's E. And then if that's the base, that's the height, then I know that my area, everybody, I believe, got this one right. Good. Pi r squared G. G? No, H. There we go. Because of course that already is, we already know that that's the area. So that one's pretty easy. So it was B, E, and H. Questions on this one? And that's about as hard as it gets, okay? So really it's just a matter of remembering the definitions. All right, now let's move on to everyone's least favorite part, which is radians, but that's okay. We will make sure we understand. So let's start off not too hard. A sector is part of a circle's area that is defined by the central angle. The ratio of the sector's area to the circle's area, pi r squared, is identical to the ratio of the central angle to the total measure of the angle. They're kind of just giving you a rundown of what everything means. Which option represents the formula for area of a sector? So we're not going to do radians yet. We're going to get to it in the next part. So for now, we're still talking about degrees. So this is pretty much how we usually do this. If you have a number, whatever this number is, we're going to do theta over what? Over 360. And on the other side of that, since I'm looking for the area of the sector, we're going to call that A. What goes underneath in this section over here? Pi r squared, because the area of the sector, remember, it's part over whole. Okay, so the part, the small angle over the whole circle, is going to be equal to the small area over the whole area. And we know that the area of a circle is pi r squared. So to go from this to one of these answer choices, what do I have to do to both sides? If I'm solving for A, I'm trying to get A by itself, right? What should I be doing to both sides of this proportion? Times pi r squared. On both sides, because that cancels it out. And I'm left with A equals theta over 360 times pi r squared. Now this is the formula for sector area in using degrees. Using degrees. And of course, that's answer choice D. However, now we've got part B. I want to do the same exact thing, but this time I want to use radians instead of degrees. So we have to think about this, because remember, we're doing part over whole over part over whole equals part over whole. Don't forget that that's what we're doing. So if that's what we're doing, I need to do theta over the whole circle. We know that a whole circle is 360 degrees, but who remembers from Friday's class how many radians are in a whole circle?
6.28.
6.28, which we want to keep that using pi. How many pi's is 6.28?
2 pi.
2 pi. So this is 2 pi. Now let me just make sure we understand. One circle is 6.28 radians. And 6.28 is 2 pi's. So there's 2 pi radians in a whole circle. Now on the opposite side, does anything change? So should I write anything different than what I did over here? Are there any degrees on the right side over here? Are there any degrees?
Isn't it like 180?
Are there any degrees written
no,
over
no.
here? No degrees, so I don't have to convert anything. The only time where I had to turn these degrees into radians. That was the only thing I had to do. The right side stays the same because there's no degrees in that calculation. And now I'm basically going to do the same thing because I want to get A by itself. So these cancel out, and I'm left with A equals theta over 2 pi times pi r squared. Does anything cancel out?
The pi?
The pi's cancel out, yeah. The pi's cancel out. So the formula, instead of using degrees, the formula using radians instead. I have to delete a couple things because I'm running out of room. For radians, the formula is A equals theta r squared over 2. I kind of bunched it all together. Okay, so it's the same formula. Think about it. Radians and degrees are just 2 ways of measuring the same thing. It's like using feet versus meters, or ounces instead of milliliters, or I don't know, seconds instead of hours. Okay, it's just 2 different units that are used to measure the same thing. Meters and kilometers, yeah. So just make sure that you're aware that sometimes you might see it in radians and sometimes you might see it using degrees. And the best thing that you can do is read carefully because it will probably tell you inside of the problem which one it is. If you see a number like 360 or you see a number like 180, it's probably in degrees. If you don't see those numbers, then it's probably in radians. So any questions on this one? How many radians in a whole circle? How many radians in a whole circle?
6.28 or 2
And
pi.
2 pi. So the big takeaway is that 360 degrees equals 2 pi radians. And we can use just rad. When you just see the word rad, that just means radians. Okay. So with that in mind, let's take a look at this one. I'm going to do these together because I just want to make sure we understand it. So Ashley is studying the circle below, and she wrote the following steps. What did Ashley derive? So let's just see what Ashley is doing. Ashley wrote theta over 2 pi equals s over 2 pi r. We know that theta is the angle measurement. So what's this?
The radians?
Yeah, this is the total radians in the circle. On the opposite side, she wrote s over 2 pi r. What's 2 pi r? The circumference, good. So if she's doing the circumference, what is she trying to find? Is she trying to find the area of the sector, or is she trying to find the arc length?
Okay.
Arc length, yeah. So this means that that's arc length. Now, what did she do in this next step? She seems to have multiplied times 2 pi r. Why is she multiplying times 2 pi r? Why is she multiplying times 2 pi r?
Oh, to get the S by itself.
To get s by itself, exactly. And when you do that, what happens is on the right side, they cancel completely. And what happens on the left side? Let me write this on the next line. So right here, I have pi over 2, or theta over 2 pi times 2 pi r. What happens here? Does anything cancel? The 2 pi, good. The 2 pi cancels, so s equals pi r. This is the formula for arc length, but it's the formula for arc length if you're measuring in radians. In radians. So it's the formula for arc length, but in radians. What would be the difference if I started at the beginning, but I wanted to do it in degrees? What would I have to change about this proportion if I wanted to use degrees instead?
Instead of like the radians, we would have put 360.
Instead of writing 2 pi, we would have written 360. So really quickly, with that in mind, let's just look at the difference. Oh no, okay. There we go. This is my formula in radians. Now let's do the formula in degrees. Nothing changes on the right side. I'm still going to multiply times 2 pi r, which cancels out. But is anything here going to cancel? Does anything else cancel on this side? No. So the formula in degrees will look like this. So I'm out of room. So it's something that you definitely just want to write down in your notebook, okay? The formula in radians and the formula in degrees. And this is for arc length. And then on the previous page, I had it for area. So something to just be familiar with because you might see this come up on your test as well. So I'll give everybody about 30 seconds to write it down. And if anyone wants me to go back to the previous page, I can do so as well. All right, anybody still writing for these formulas? Anybody still need to write these formulas? All right. Okay, so let me see. We have a little bit of time left. I'd rather do this question. So here's an interesting one. In the given image, theta 1 is equal to theta 2. And the angles are measured in radians. So see, they usually tell you when it's going to be radians and when it's going to be degrees. So we just want to read carefully. And then it says, which of the following must be true? So let's start by thinking about looking at the examples that we see and trying to figure out what it is that they're doing. because they're kind of making these proportions, right? I'm seeing S1, R1, S2, R2, and then I'm seeing theta over 2 pi or theta by itself. And we kind of want to go back to what we just wrote down and think about how to put these together, because S is arc length. S1 and S2, those are the arc lengths. R1 and R2, those are my radii. So which formula am I going to use? The formula for arc length or the formula for area?
Arc length.
Arc length, definitely. So first, let's call this one circle number 1. And then we'll look at circle 2. For circle number 1, we know that the arc length, using the formula, we just wrote it down, arc in radians, arc length equals pi r. But we know that pi is equal, pi 1 is equal to pi 2. And all of these are S1, pi 1, and R1. For circle 2, it's the same thing. Oops. So I'm just using the formula so far. But like I said, I know that pi 1 is equal, I keep saying pi, I'm so bad at that. Theta 1 is equal to theta 2. Those are equal. It tells us. It tells us. So let's do this. Let's rearrange this formula to get theta by itself. If I want to get theta by itself, what would I do to both sides of this equation? To get theta all alone.
Multiply by R1.
Multiply by R1?
Oh no, R. So get the theta by itself. Oh, divide. Oh my gosh.
Divide by
No.
R1. That's okay. We divide by R1. So I know that theta 1 equals S1 over R1. And then same thing on the other side. I can divide by R2, which means that theta 2 equals S2 over R2. But what did I just say? Theta 1 and theta 2 are equal to each other. So using substitution, I know that this also has to be equal to that. If the two thetas are equal to each other, then these two ratios should be equal to each other as well. So I know that S1 over R1 equals S2 over R2, and both of those are both equal to theta, which is the same. Theta 1 and theta 2 are both equal. So, long story short, answer choice C, right? Yeah, C. So I wanted to show you guys this question because it's very tricky, because you kind of have to think about how do I take what I know and turn it into one of these answer choices? How do I manipulate the equations and the formulas that I already know in order to make sense and make it look like one of these? So the steps are right here. Take a moment. I know that class is pretty much over. But if anyone has any final questions, feel free to stay for a couple seconds and ask. And tonight, do your best to review, watch a little bit of videos, do a little Khan Academy if you want to just review things. But I think you guys are in pretty good shape for tomorrow's test. So it's just a matter of making sure that all those little formulas, all those little rules for the properties of circles, they stay in your brain and you don't rush through the test and forget little things like that, okay? So best of luck studying tonight, and I will see everybody tomorrow.
Wait, do you know how many questions there are?
It's 13 questions on part 1, and I can't remember part 2, unfortunately, but I'll look it
Okay.
up later.
Thank you.
Bye,
Bye.
everyone.
Miss.
Bye.